A little theoretical, but it teach you some bushings and bicycle spokes which were not even stainless steel. They were chrome plated steel. Now we chrome heat hardened stainless steel 302, 320, 420. This is the softest, this is the stiffest, this is the wire that is very commonly available in the market, but not as easy to handle as this. And this was the original Ilizarov wire. Even now, wire is that. Materials. Rings, stainless steel, come. Titanium alloy has come in the last 6 years. Carbon fiber alloy came about 10 years and slowly disappearing, almost going out. Reinforced fiberglass keeps coming and going. Aluminum alloys have now come about 6 years back and they are there to stay. For K wires, SS, titanium and coated SS. And for Shan's pins, titanium. Let's look at the advantages and disadvantages. For the rings, the best material should be lightweight, durable, elastic, resilient, non-weight bearing and radiolucent. What does a carbon fiber ring do? It is lightweight, it is radiolucent. Actually, all these factors are not available with stainless steel. They are not lightweight, they are durable. They are not very elastic, they are not very resilient, and they are not radiolucent. So these problems we are trying to change. They are not reusable, they get fatigue fracture, and they are more expensive per case, or probably most expensive per case amongst all Ilizarov rings. This is new, but it is not reusable. One time use, break it, crack, expensive. I am now trying 3D printed rings made out of plastic for each individual patient. I will let you know when I get some success. These are now staying. They have been in use for last a decade with wonderful results. They are lightweight, elastic, reusable. Though they are not radiolucent, they are slightly radiolucent. But they are expensive. And then of course the aluminum alloy rings. They got all the advantages: lightweight, elastic, reusable, fatigue resistant, and minimum radio opacity, and not as expensive as titanium. For rings, the best material should be stainless steel if the patient cannot afford it. 500 rupees for a half ring and you are home. I have just started making it. It's also available internationally, and about 1,200 rupees per half ring. That should be the way to go. For wires, the best material should be rigid, elastic, resilient, non-deforming and biocompatible. To date, no material matches stainless steel. Titanium wires of 1.8 thickness are just too flexible and if heat hardened too brittle to be used practically. What is the solution? Make the wire thicker, use Shan's pins, fold the wire, make the frame more stable to prevent plastic load. What is a plastic load? Tension wire is stretched like a piano string, and now at this stage we start loading. Especially when you want to bend the wire starts pulling, and that will not go back. So that will loosen, and that causes pin drag, that causes pain, that causes complications. Making wire thicker has the following problems. Wire thicker than 2.2 mm are non-tensionable. Thick wires act as cantilever pins. Thicker wires, more tissue trauma. Coating the wire to inhibit bacteria and reduce pin. This lot of work is happening, and this is the way to go forward. Jenison studies about copper. I am also doing some studies in copper coating. It has got excellent bacterial inhibition, but the released ions are toxic to human body. Iodine again has got antibacterial properties. Coating is not advised because leach is not tolerated. It is nephrotoxic. Nano silver is showing a lot of promise. There are all the world which indicate that nano silver coating of stainless steel wires may be a way to go forward. Ultra thin coat of silver ions, less than 100 nanometer thick. Very simple. You take a silver nitrate solution and dip the wire in it, put a cathode and touch the anode to the silver. In 30 seconds, about 50 to 100 nanometers get coated on the rod. Jenison study shows that nano coating silver is a way of future, and very little silver can be used to coat lot of wires, making it very inexpensive. Increase the number of wires to balance the loads. The only problem happens if you put tension a wire at 120, 130, 140, 150 as the Ilizarov people do in Russia. Our patients don't tolerate it and plastic deformation occurs. So keep it at 100. Put 3 wires instead of 2. Try to get as close as blood to 1980. Not always possible. Addition of 3rd wire. Bring individual loads below around 50 Newton per wire. Delay weight bearing. Partial weight bearing can be given. That's an interesting concept. This is called fracture track. What does? It's an external fixed weight supplement mounted at the ring wire junction. This calculates the forces across each wire. So the frame can be balanced or patient put on NWD to decrease loads. If you suddenly find the loads are increasing above 50 newtons on loading and the wire is going to go for plastic deformation, the fracture track and see how much the thread is moving. If it's moving, stop weight bearing for 10 days, a month, let the bone become stronger and dramatically reduces the need of repeated x-rays. Chalya was telling in the morning that we have to take very repeated x-rays. The same with they were talking about bi-weekly, monthly, every month for next 1.5 years. You can reduce it dramatically because just looking at the fracture track, you can say whether wires are being properly loaded, whether rigidity is going to form, whether it's easy. Shank spins. Most bones have subcutaneous or safe corridors for easy insertion, but it does not transfix the tissues, does not violate the medulla if used unicortical, and half pin gives almost as much stability as a stretched wire. Disadvantages: greater tissue trauma while inserting, needs pre-drilling, cantilever effect, greater stiffness in linear direction, and detrimental to Ilizarov. Disadvantages: they make a Ilizarov frame static. And you see, it's not dynamic, so it is bending. These are spots where it will bend, a K-wire. Improvements in shank spin: you increase the diameter from 6.5 to 8 mm. Shank spins made in titanium 8 mm or nano silver or copper coating SS spins. Now what is happening currently is 7.5 or 8 mm shank spins in titanium along with hexabot frames is what is catching the fancy in Europe. Shank screw recommendations. Now today we had heard both the schools of thought. On one side was Dr. Shibujan Varki, who did not deviate from the original side, and on the other side was Dr. Agrawal, Dr. Manish Dhawan, Dr. Jhanjhanwala, who are the fairly Taylor school. So I am not telling you which is superior. You will hear both these in all conferences. To date there has been no consensus whether it should all wire is better or adding shank screw makes things easier. I was surprised to see the phenomenal amount of length Manish got by his shank spins. And is equally surprised to see phenomenal amount of length gotten by Varki with his all constructs. So both methods work. What works better in your hand should probably be right. Right now we don't know which is actually superior. So in Ilizarov thing he said never use shank screw, use all wire construct, never exceed tension beyond 120, compensate absence of 1990 spread with drop wires, extra wires, proportionately reduce the need for tension kilograms to make it below 120, and judicious use of all wires for cross pull. And opposite of this Mr. Katani, Taylor, an American school. They say 90 degree spread of 2 shank screws through easy safe corridors gives adequate stability. There is no difference between wire and all pin constructs. This is so easy that you can go home tomorrow and put your first Ilizarov. But the one before is not all that easy. It needs a longer learning curve, which is another disadvantage. This is Mr. Taylor, who has made the Taylor special frame. He says don't use K-wires. Difficult for surgeon, plastic deformation over tense wires. Switch to all shank screw constructs and modify the shank screw ring mount to aid frame dynamization mechanics. So the stiffness of the pins he wants to reduce by the junctions. My recommendations: avoid shank screws as far as possible. Use them judiciously where inevitable. Upper femur, upper humerus are probably the only locations. Don't use them in tibia and forearm. Material paraphernalia, nuts, bolts. 304 is an excellent time-tested material, fairly inexpensive. Titanium is lighter and better, but much more expensive. Recommendations for an ideal frame. We have 3 types of situations. One who say money no object, one who says compromise on budget, one who is financially handicapped. So, If money no object, use aluminum or titanium rings, thread telescopic rods and other paraphernalia and heat treated titanium, add a fractured track to balance load. Frame will cost 1.5 to 2 lakhs per frame. Reusable in about 10 patients, making cost per patient about 10,000 rupees a frame. For budget, use ultralight rings like these, but use stainless steel accessories like these. You use SS wires and titanium charm screws. So a 5-ring set will cost about 25,000. Can be reused in 10 patients. Cost per patient is 2,500. And if it's a financially handicapped patient, use an all SS frame. This is only 13,000 for a 5-ring set. Useful in 13 cases. Works out 1,000 rupees a case. So 1,000 rupees a case is not an expensive proposition. We have been misinformed that Ilizarov is an expensive surgery. Next, the Taylor spatial frame and intramedullary elongation devices. Both are interesting concepts. Additional Rancho cubes and fracture track. So TSF, the Taylor special frame. Ori, that's for you. That's for you. You are sleeping now. Taylor special frame. So, invented by orthopedic surgeon Charles Taylor. Hexapod device based on Stewart platform. Aluminium or carbon fiber rings connected by 6 struts. 1, 2, 3, 4, 5, 6. Each strut can be independently lengthened or shortened. Online software based daily single correction. Primarily all chance construct. Computer assistant software. What you do? Every day you input into the computer. This software is controlled by the company who is selling you the product. You put in the details, you tell what angulation you want, how much I want 1 degree, as Dr. Dolke had calculated 26 degrees, 1 degree a day, correction in 26 days. So once you get an X-ray, you do a spatial frame, you do the markings, take the measurements. Though it's boring, you have to listen to it because unless you listen to that, you won't be able to do this. So you got your 26 degrees or 25 degrees or 24 degrees, then you put it in software. So the computer will tell you, do this much, this, that, do this much of turn, this, that much of turn. End of the day, it theoretically is supposed to correct. But people have actually used this tell me that sometimes it doesn't get corrected. Other one, I think I lost one slide before, I should go there and show you. That was an important slide. Now this is important because we have an overseas wanted specially a talk on this. I told him most of people may not be interested, but for him, I've just put in a few slides. I do not have any experience in this complex system. This is an expensive system. And in my view, simple common sense is preferable to a complex computer software. You are seeing it right in front of you. You are seeing the limb. You are seeing the second toe. You are seeing the tibial tuberosity. You are seeing the anterior spine. In the hand, you are seeing radius styloid, ulnar styloid, olecranon, head of the humerus. Anatomic landmarks are there. You can draw straight lines clinically and make your markings. So I wouldn't know whether it's really going to work. But then Manish again showed some wonderful cases today where without opening it, it's some magical results. So again, it's a matter of knowing it and doing it properly. Just because you have money, you don't need to buy a machine and get a software and bugger up the patient at a higher cost. We can start learning that at a lower level. This is really revolutionary. I learned about this after I saw a patient who came to me for removal of the implant. He had got it done in Italy. This is a Stuart Green, American surgeon. It's an internal distraction device. It's not Ilizarov or external in true sense. The screw turnings are done by an external remote control, magnetic. So what you do a corticotomy, you put a locking nail, you lock it distally, you lock it proximally. This portion now has 2 nuts, and by rotating the nut, these 2 will get distracted. You then close, suture it, drain him. Take out drain for 8 hours, and then starts the magnet jadoo. What is this? These are 2 strong magnets, and by moving it, exactly 1/4 turn of the nut inside will happen. So it's an internal degenerate. So remote is a twin magnet contraption. If brought close, it causes spin electric field. This turns the screw to the side turn. The patient is taught how to do it, and he can do it easily at home. So I had little difficulty removing it. I still have kept the piece with me. It's nice. Patient wanted to take it back. I also want to bring it to the conference and show it to you. And the magnets are still working. It's really magical. You keep the thing and take the magnet here and do like that, it will automatically turn at 6 inches distance. My recommendation is not a true Ilizarov modification, it's too expensive, still under trial, and most importantly, if infection occurs, the whole operation is a failure. And of course, if your patient can afford 6 lakhs, he might as well fly to Italy, get it done there, and things go wrong, let him blame that surgeon. You don't get into the game so early, let's wait for the results to come. Take home messages. Number 1, original Ilizarov is the best. No choice. Only modification of the original can be called a step forward, is a material for the ring. All other modification changes spoil the system rather than improve it. I'm sorry to be dogmatic, but then we are a basic course, so if you go home, you must take a correct message and go, not to get confused. So, all these high fancy SUVs and tailor frames and computer software, internal things, anything that costs more than 25,000 to 50,000 per patient, do not go near it unless you have done 100 cases conventionally. Dr. Manish Dhawan's hands, you will get excellent results. Dr. Ilizarov will do magic with it. Subhash Shelya will come and say, I've done this wonderfully. But for you people, don't take that message at all. You have seen a lot of complicated, done beautifully in the morning. The only one lesson you will take from the morning session is, these sort of miracles can be done with an Ilizarov. But these sort of miracles do not happen on your first case. And very, very nicely said by, I think, Amar or Shibu, that they say it's a long learning curve. Learning curve should not be used at the cost of our patients' sufferings. This is not like a fellowship where you go for a knee replacement fellowship, learn half a dozen cuts, and you do it precisely in your own house. Here, even if you spend years, you may not get the trick right. In the first case itself, you may get it right. So my philosophy is, not all surgeons are competent to do Ilizarov because God has not made everybody identical. Some people think in pictures and then very easy to understand things and do it magically. Some people, even the best instruments, things go wrong. So another to carry home message, go home, start doing it. If you get miracles in the first 3-4 cases, you will become a dedicated Ilizarov surgeon yourself. If you get disaster after disaster, do not experiment more. Leave it to people in whose hand results will be better. Choose something more suitable for you. Please don't mind if it sounds harsh, but this is a take-home message for you. Another take-home message, begin with all wire constructs and master the art of pin placement. This is very important. Why? It is very easy to learn chance screws, and after that you will never go back to wires. Struggle, learn to make an all wire construct. Later on when you become expert, in the interest of saving time, you can add chance screws. Absolutely done. But don't do it. Okay? Use only 1.8 mm wires as far as possible. Use extra wires with a single ring. Use aluminum or titanium rings. And chance screws only for proximal femur and humerus. Thank you very much. And 2 more talks are there. One by Dr. Manish Dhawan about post-operative management, and one by Dr. Lunjanwala about Ilizarov and congenital pseudo-orthosis of tibia. After that, this Ilizarov session will end. I have very, very beautiful half-an-hour talk for you, orthopedics, usual and unusual, which is based on the unusual experiences in my life, and that speaks about many things besides orthopedics, which you will really enjoy it. And we have another exceptional speaker with us, Dr. Arvind Divakar from Lalitpur.